Hi there, in this video we're going to talk about partial fractions. In order to do that, first we have to talk a little bit about how we add fractions, especially the type of fraction that has some kind of polynomial in the denominator. For now, we'll just keep the terms fairly simple. They'll just be linear, so no exponents on the variables. Let's take a look at how we would do this. So in case you forgot, in order to add fractions, they have to have a common denominator. And these two fractions clearly don't have a common denominator. The first denominator is x plus 1. The second one is x minus 3. So what we have to do is find a least common denominator. Or in other words, the least common multiple of the two denominators. So because they don't really have anything in common, the least common denominator is just going to be their product. So let's just write that on the side. So least common denominator is their product, which is going to be x plus 1 times x minus 3. And that's equal to, well, x squared minus 3x plus x minus 3. And that, of course, is equal to x squared minus 2x minus 3. Okay, so our denominator is going to be that. But let's take a look at what happens when we change that denominator. So what we're going to do is we're going to say that this is going to be 3 times x plus 1. And in order to turn this this denominator into the least common denominator, we need to multiply it by x minus 3. So we're going to multiply the top and the bottom by x minus 3. And we'll get something that looks like this. Okay, and then we will add to that, well, 2 over x minus 3. And in order to turn that denominator into the least common denominator, I'm going to multiply the top and the bottom by x plus 1. Okay, and this is all equal to, well, I've got 3x minus 9 over, well, x squared minus 2x minus 3 plus 2x plus 2 all over x squared minus 2x minus 3. Now I can go ahead and add these together, and I'll be left with 5x minus 7 all over x squared minus 2x minus 3. So, just to be clear, what we've shown is that 5x minus 7 all over x squared minus 2x minus 3 is equal to, 3 over x plus 1 plus 2 over x minus 3. And why is that relevant? Well, let's think about this. If I asked you to integrate this, you might have a bad time. It's not a very nice thing to integrate. However, if I asked you to integrate this, well, it wouldn't be too bad. This would be some kind of function of the logarithm, right? So our goal is to have the ability to be given a function that looks like this and turn it into a different form that looks like that, so that if we're asked to integrate it, we can do so easily. Let's take a look at how we would go about doing that. Okay, let's try this example. We've got x plus 5 over x squared plus x minus 2. And if we were asked to integrate this, my guess is that we would struggle. So let's see if we can split it up into something that's a little bit easier to integrate. So, in other words, I'm going to write it as what we call partial fractions, okay? So, the first thing I want to do is factor the denominator, okay? So, I'm going to factor the denominator. Okay, so I've got x squared plus x minus 2. So, I'm looking for factors of negative 2 whose sum is positive 1. So I think what I'm looking for is the pair positive 2 and negative 1. So that means that x squared plus x minus 2 is equal to x plus 2 times x minus 1. So I'm going to say that this is equal to, I'm going to introduce a new variable, I'll call it capital A, and that's going to be the numerator on x plus 2. I should say the numerator on the fraction whose denominator is x plus 2. And similarly, I'll write b over x minus 1. So my goal now is to figure out what happens in those numerators. So how do I figure that out? Well, what we're going to do is we're just going to solve for them. So in other words, I'm going to multiply both sides of the equation by this. So effectively that will eliminate the denominator on the left-hand side, and I'll multiply x plus 2 times x minus 1 to both of these terms, okay? So what I'll get is something that looks like this. I'll get x plus 5 is equal to a times x plus 2 times x minus 1 all over x plus 2, and maybe you can see where this is going, plus b times x plus 2 times x minus 1 all over x minus 1. Now these are going to cancel out, this x plus 2 and this x plus 2. These are going to cancel out, x minus 1 and x minus 1. And we'll be left with a nice little equation that says x plus 5 is equal to a times x minus 1 plus b times x plus 2. Now it's our job to solve this. So it's actually not as hard as you think, because I can easily eliminate either a or b just by a careful selection of x. Keep in mind that this equation is supposed to be true for all values of x. So I can choose my own value of x and see what the other variable turns out to be. So what I mean by that is I'm going to say let x equal 1. When x is equal to 1, I'll get 1 plus 5 equals a times 1 minus 1, that you can probably see what's happening there, plus b times 1 plus 2. Or in other words, well, this turns to 0. I've got 6 equals 3b. So in other words, b is equal to 2. Nice. Now all I have to do is figure out what happens to a. And I can do exactly the same thing. So I'll do that over here. I'll say let x equal negative 2. When that happens, I get, well, I'll have negative 2 plus 5 equals a times negative 2 minus 1 plus b times negative 2 plus 2. And this disappears because negative 2 plus 2 is 0. 0 times b is 0. And I'm left with, well, negative 2 plus 5 is positive 3. I get 3 equals a times negative 3. Or in other words, a is equal to negative 1. Now that I've solved for a and b, I can plug them into this equation right here. So we're going to replace a and b with the values that we found, and that's going to be our new expression. If we were asked to integrate that function, the original function that we were given, x plus 5 over x squared plus x minus 2, well, we can simplify that using partial fractions. So we'll note that the integral of x plus 5 over x squared plus x minus 2 dx is equal to, well, first of all, we'll factor the denominator. So we've got x plus 5 over x plus 2 times x minus 1 dx. And that's equal to the integral of, and I'll turn that into one big set of brackets. And what did we have here? We had that this is equal to negative 1 over x plus 2 plus 2 over x plus 1, or sorry, x minus 1 rather, dx. And we'll split this integral up. So I've got that this is equal to the integral of negative 1 over x plus 2 dx plus the integral of 2 over x minus 1 dx. And from here, it's just stuff that we've already done before. So this is negative the integral of x plus 2 to the power of negative 1 dx plus 2 times the integral of x minus 1 to the power of negative 1 dx. And from here, it's just taking some logarithms. So I'll write that this is equal to the negative ln of the absolute value of x plus 2 plus 2 times the ln of x minus 1, all plus c. While we're on the topic of integrating rational functions, I thought we could take a look at a question like this. So you'll notice that the numerator has degree 3 and the denominator has degree 1. That means that we can actually do long division on this to simplify it. It may have been a while since you've done any long division, but the algorithm is exactly the same. So let's see what this looks like. Okay, so I set this up the same way that I would have written a long division question back in grade school. So one thing to notice is that there's no coefficient on x squared and there's no constant, but I'm still going to write them inside this square or this division symbol. So don't forget about those terms. Those are kind of like writing 0 in your place value. So what I'm going to do is I'm going to say, okay, how many times does x go into x cubed? Well, the answer to that is exactly x squared times. And I'm going to multiply x minus 1 times x squared and find the remainder. So I've got x times x squared is x cubed, and negative 1 times x squared is negative x squared. Now I do the subtraction, and keep in mind I'm subtracting the whole polynomial there. So I've got x cubed minus x cubed, which is 0x cubed. I won't bother writing that. And I've got 0x squared minus negative x squared, which is equal to positive x squared. And now I'm going to bring down this next term, and I've got x squared plus x. And I do the same thing again. I say, how many times does x go into x squared? Well, exactly x times. And now I have to find the remainder. So x times x is x squared. Negative 1 times x is negative x. And now I do the subtraction. So x squared minus x squared is nothing, so I won't write anything. And x minus negative x is 2x. And finally, I bring down that 0. So I've got 2x plus 0. And I ask myself one more time, how many times does x go into 2x? Well, it goes in exactly twice, but let's see what the remainder is. So I know that x times 2 is 2x, and negative 1 times 2 is negative 2, and I'll do the subtraction. 2x minus 2x is nothing. 0 minus negative 2 is positive 2. So that means that we have a remainder of 2. So what does that mean? It means that x cubed plus x over x minus 1 is equal to x squared plus x plus 2 plus the remainder, which is actually 2 over the divisor, which is x minus 1. Now, integrating that thing on the left, the original function, might be a little bit tricky. Integrating this, it's not too bad, because we can split it up into smaller integrals. This is easy to integrate, this is easy to integrate, this is easy to integrate, and well, this isn't super hard to integrate, but we can do it quite easily, actually. Again, it's just another log function. So let's give ourselves a little more room here, and we'll write that the integral of x cubed plus x all over x minus 1 dx, that's equal to the integral of, and I now have to open some brackets here, I've got x squared plus x plus 2 over x minus 1 dx. And I'll split this up into smaller integrals. I'm going to get the integral of x squared dx plus the integral of x dx plus the integral of 2 dx plus the integral of 2 over x minus 1 dx. Okay? Now, this is equal to 1/3 of x cubed plus 1/2 of x squared plus 2x plus 2 times the ln of the absolute value of x minus 1 plus c.